In this video, we're going to discuss about the alternative definition of continuity. So let's recall. Okay. So recall natin yung definition ng limit. Limit ng f of x as x approaches c is L if and only if for any positive epsilon there must exist a positive delta such that 0 less than, or the distance between x and c must be greater than 0 or must be positive but less than delta, implies the distance of f of x and L is less than epsilon or as small as possible. Okay? So for this definition, hindi ibig sabihin yan yung limit ng f of x ay equal sa value ng f of c. Meaning kapag sinubstitute mo yung c sa f of x, yung magiging value niya ay f of c. So hindi ibig sabihin nun, okay, this does not mean or does not say yung f of c o yung value ng function at x equals c ay equal sa L. Okay? So, may mga limit na nag-a-approach siya sa L pero hindi yon yung value ng function. So, parang ganito kung i-graph natin. Let's say, ito yung graph. Ito yung C. Then, ito, hindi pala siya, circle siya. So, ito yung limit. Let's say, ito yung limit. Okay? And then, let's say, ito yung L minus epsilon, L plus epsilon. Okay? Then, let's say, ito yung C plus C minus delta, tapos ito yung C plus delta. So, ito yung limit niya. Ang limit niya ay L. Kasi nga, yung any values ng x dito, pag nilagay mo sa f of x, except f of c. Pag nilagay mo sa f of x, nasa loob ng L minus epsilon, L plus epsilon. But let's say, yung f of c natin ay somewhere sa labas. Okay, let's say ito. So, naka-circle to, tapos ito yung f of c. So, ito pa rin yung limit niya, yung L. But yung L, hindi siya equal sa f of c. So, pwede yung ganyang case na mangyayari. So, yung definition ng limit, hindi niyan sinasabi na ang limit ay yung value ng f of c. Okay? Nag-a-approach siya sa L, but that doesn't mean that L is equal to f of c. Now, dun tayo sa definition ng continuous. I-recall natin yung continuous. F is continuous at C if and only if for any positive epsilon there must exist delta such that the distance between x minus c less than delta implies the distance between f of x minus f of c is less than epsilon. Nakita niyo yung halos pagkakapareho ng definition nila. Yan o. Halos pareho ng definition nila sa limit tsaka sa continuous or continuity. Pero kung mapapansin nyo, dito ang limit ay f of c. Kasi yung distance ng f of x tsaka f of c is less than epsilon. Kumbaga yung L dito, which is pwedeng equal, pwedeng not equal sa f of c. Okay? Dito, naka f of c siya. So dito sa case na to, ibig sabihin yan, yung mismong limit, siya yung f of c. Yung mismong limit ng f of x as x approaches c. Dito kasi ang limit ay L. Pero yung L, hindi ibig sabihin nun equal kagad sa f of c. Pero dito, yung limit niya, since yung distance ay less than epsilon, siya mismo yung f of c. So, yun yung sinasabi ng definition ng continuity. Okay? Kumbaga sa graph, similar dito, okay, kung i-graph natin, let's say, ito yung C, ito yung f of C. Ito na mismo. Tapos, this is, let's say, f of C minus epsilon, f of C plus epsilon. So, yan. So, kanya yung itsura ng graph. So, let's say, ito yung ating ito yung C minus delta, C plus delta. Okay? So, yung limit niya, siya na rin mismo yung value ng f of C. So, yun yung sa continuity. Sa limit, ang limit ay yung L, which is hindi palaging equal sa f of C. Okay? Posible kasing mangyari to. Pero sa continuity, ang sinasabi niyan, yung limit na yan, continuous siya kapag yung limit na yan ay equal sa mismo sa f of c from this definition. So therefore, meron tayong alternative definition for continuity. Okay? So instead of using the epsilon and delta definition for continuity, pero dyan din galing yun, yung definition, yung alternative definition. So, alternative definition, and ito yung usually ginagamit sa ibang books. So, alternative definition of continuity, let C be a cluster point of A. Let A be a subset of R and F function from A to R. Okay. Then, number 1, dapat define yung value natin na f of c. So, f of c must be defined. And dapat meron siyang limit. So, yung limit ng function as x approaches c exists. And then, for the third definition, for the third condition, dapat yung limit na yon na nag-e-exist sa x approaches c is equal to f of c. Okay? So, yung definition na to, yung limit na dapat equal sa f of c, galing yan dito. Na ito, mula sa limit ng function, pero sa limit, ang limit niya ay L. Sa continuity, f of c na mismo, yung limit. Yung value na mismo. Okay, so ito yung alternative definition ng continuity. Now let's have the sequential criterion for continuity. So let's have the function a from a to r. This function is continuous at point C, element of a, if and only if for all sequence x sub n approaches c. This must imply that the sequence of f of x sub n approaches f of c. Okay, so kumbaga yung mga values ng x sub n, pag nilagay natin sa function, dapat equal doon sa f of c. So yun yung sequential criterion. And then, of course, kung meron tayong sequential criterion for continuity, meron din tayong discontinuity criterion. So dito, let A be a subset of R, F a function from A to R, and let C be element of A. F is discontinuous at C if and only if there exists a sequence. Meron tayong isang sequence such that yung sequence na yon nagko-converge sa C. Pero kapag nilagay mo na siya sa function, yung sequence ng function f of x sub n, hindi nag-converge sa f of c. Okay? So, doon natin masasabi na discontinuous at ang function. Okay, so proceed tayo sa example. Okay, so for example, number 1, show f of x defined by 0 if x is not equal to 0, 1 if x equals 0, is discontinuous at x equals 0. Okay, so for our proof, so ipoprove natin na yung function na to ay discontinuous. So mula sa definition, di ba? So balikan natin yung definition. So dapat makapag-provide tayo ng sequence. Na yung sequence nag-a-approach sa C, pero yung f of x sub n, yung sequence of f of x sub n, hindi nag-a-approach doon sa f of C. So, ang unang gagawin natin, mag-provide tayo ng sequence of x sub n. So, let's say, since 0 yung pinag-uusapan nating x, so let's say, yung sequence natin is defined by 1 over n for all natural number n. Then, yung 1 over n na yan, magsisimula yan sa 1 and then 1 half, 1 third, 1 fourth, 1 fifth, and so on. So, nagde-decrease siya and saan siya nag-a-approach? Nag-a-approach siya sa 0. So, yung limit ng x sub n or yung limit ng 1 over n is 0. Okay? Which is ito. Now, kung isa-substitute natin yung x sub n sa function, so but the sequence of f of x sub n is sa substitute natin to, since ito ay 1 over n, so sure tayo na yung 1 over n ay not 0, not equal to 0. Substitute natin sa function, this is always 0. So this is 0, 0, 0, 0, and so on. So, puro siya 0. So, therefore, ano yung limit? Ano yung limit ng f of x sub n? Okay? Or saan nag-a-approach yung sequence of f of x sub n? Sa 0. So, and so, limit ng sequence is 0. Okay? So, therefore, or thus, yung limit ng f of x sub n, limit ng sequence f of x sub n is 0, which is not equal sa 1. So, ba't kailangan equal sa 1? Kasi yung 1 na to, yung 1, siya yung value ng f of 0. Kapag sinubstitute mo yung x sa f of x, since x is 0, yung value ay 1. So, as you can see, yung f of 0 or yung limit ng sequence of function ay not equal sa f of 0. So, yung limit ng sequence of function or yung sequence of function, hindi siya nag-a-approach or nagko-converge sa value ng f of c or f of 0. So, parang ito. Yung sequence na to, hindi nagko-converge sa f of c kasi magkaiba sila ng value. Yung value ng function tsaka yung limit ng sequence of function. So, therefore, pwede nating ma-conclude na yung f is discontinuous at x equals 0. Okay, so let's have another example, number 2. Show that the function f of x equals x squared is continuous at the point x equals 0. Okay, so magkakaroon tayo dito ng meron tayo ditong dalawang parts. Yung una, discussion and then proof. So discussion muna. From the definition, so gagamitin natin yung epsilon delta definition ng continuity. Okay, so balikan natin yung epsilon delta. So dito sa dito sa epsilon delta, same lang naman siya sa limit. For any positive epsilon, dapat makapag-provide tayo ng delta. Such that for this condition, dapat mapakita natin to. But this time, dapat mapakita natin na yung limit ay yung value ng function f of c. Okay? Hindi lang basta L. Or hindi lang basta certain value na less than epsilon. Okay? So, for discussion, hahanapin natin yung delta. So, given positive epsilon, we want positive delta such that the distance between x and 0 at x is 0 kasi, diba? Bakit 0? Kasi, kapag sinubstitute natin yung 0 sa f of x, magiging 0 yung value, di ba? Kaya 0 yung ginamit natin para ito yung f of c, no? Dito pala sa ano yun, sa isa pa. So ito yung value pa lang na 0 implies, ito nga yung sinasabi ko, yung x squared minus 0. So pag sinubstitute natin, para magiging ano siya, f of x minus f of c. Okay, less than epsilon. So this is absolute value of x squared less than epsilon. So pwede na natin tanggalin yung absolute value of x squared kasi naka-x squared naman siya. Tapos square root natin both sides. So x is less than square root of epsilon. So i-take natin. Take natin yung delta to be the square root of epsilon. Okay, so punta na tayo sa proof. So for our proof, let epsilon be greater than 0 and choose delta to be equal to square root of epsilon. Then, absolute value of x minus 0 less than delta implies, okay, so yung pa rin, x squared, yung f of x minus yung f of c, that is 0, is less than in-square natin to. Okay? So, square natin yung x minus c, magiging x squared, tapos minus 0. Okay? Kasi ito, x squared lang naman to eh. 'Di ba? So, x squared lang, tapos lagyan na lang natin ng minus 0. So, less than, syempre may square din to. So, delta squared. Okay? And then, delta squared, that is x minus 0 less than, ang delta natin ay square root of epsilon. So, square root of epsilon squared. And this is also x squared minus 0 less than epsilon. So, yan. Napakita na natin. F of x minus f of c less than epsilon. So, yun na yun sa definition. So, this shows that limit of x squared as x approaches 0 is equal to 0, which is that 0 is the value of f at x equals 0. So, therefore, f is continuous at x equals 0. So, this is done.